Okay, good evening, everyone. Thank you so much for joining the Women in IoT meetup hosted here at New Star. We are so excited to have you here and very excited to have Kai Kreuzer, founder of openHAB and project lead at Eclipse Smart Home, giving a presentation tonight. He will give a presentation and we'll have a brief Q&A at the end. If you need to use the bathroom or top off your drink, you're welcome to do so quietly through those doors or at that table respectively. And without further ado, please welcome Kai.
Oh, thank you very much. It's a pleasure to be here. So, I'm going to talk about smart home stuff, and she mentioned two projects, openHAB and Eclipse Smart Home. They are both open source projects. They are linked to each other. Actually, openHAB is using Eclipse Smart Home underneath. I will explain some of the details later on. But to tell you why I'm actually dealing with smart home myself and how I came to this whole topic, I'd like to introduce myself, but not really myself, but I'd rather like to introduce you to my electrical cabinet at home, which looks like that. I've tried to list about what I have built into this house, what I can actually automate and do there. And I built a house in 2008, so 8 years ago. And I was always a lazy guy. I definitely wanted to have electric shutters, and I didn't want to have to walk around too much. So I really built in all the hardware and sensors and whatever was possible. And building a new house was the only option for me. So I convinced my wife it has to be new. I don't want to buy any house which is already there, because I can't put all the cables in that I would want. So I did all that, but then noticed that, well, actually the interesting part was still missing, and that is the software to now really automate things. Not that I'm just able to control it, but really to have that all working together. Now, that's why I started openHAB in 2010. That's where development started. I was looking around first at other open source projects and other stuff to use, but none of that seemed to me like, well, from architectural perspective and from programming language, something where I would say, okay, I want to use that for the next decades and want my kids to learn that in order for them to take over sometime later. So, if you look at smart home gadgets today, so if you're not having the chance to build something from scratch, but you're just buying something off the shelf, what is out there, the usual setup you will end with looks about like that. You have many different smartphone apps for all your devices, but they're really all silo applications that you have there usually. And the smartest thing in your house is still yourself, because you have to launch the one app, get notifications from that, launch another app, do something there. But the stuff is simply not integrated with each other. If you look at the infrastructure, how that is all built usually, all the devices do an internet connection to the cloud server of the manufacturer. The smartphone app then communicates through that. That's definitely the simplest approach to do that. Now, if you want to make these things interact, the problem is that the devices themselves, there are so many different protocols and standards out there that they simply can't talk to each other. On the cloud side, we have our web technologies, JSON, REST APIs, whatever, and this is fairly standardized. So the very obvious approach is to say, well, let's do the automation logic right here also in a cloud service and integrate my devices with that. That's really from industry perspective the straightforward way, and that's, for example, services like IFT, if this then that, which offers such functionality, or also the Works with Nest program, which follows this approach. But from a consumer and end user perspective, that is really a nightmare for me, because you have all these different internet connections. You're completely dependent on that, so you can't switch your light anymore if your internet is down for a moment, whatever. And one thing to remember on that is also that there is actually no cloud, it's just somebody else's computers out there, right? And usually you might say, well, I don't mind that much if it's hosted there at some nice startup company, but I recently also bought a webcam because it had a cool wide lens eye, and I hooked it up at home, then tried to access the video stream and noticed that, well, there is actually no local video stream. No, this damn camera was sending all the video stream to some Chinese server just to give it back to me through some smartphone app with Chinese characters, which I couldn't understand. And that was the only way for myself to get hold of my videos there. And I directly unplugged that thing and only carry it around with me as a bad example of how not to do it, right? So in smart home, we talked about the smart aspect, but there's a second word, the home. And so as all your devices are in your local area, in your local area network, in your intranet actually, you hook them up there. You would also want them to communicate locally and have your data stored locally. And that's why IoT for myself doesn't mean Internet of Things, but the intranet of things. And there might be situations, of course, where you need some cloud service if you want to remotely access your stuff, if you want to do some very fancy artificial intelligence algorithms or whatever, for which you need powerful cloud servers. But this should be then dedicated for these special purposes, a connection that the user decides, okay, he wants to use that, and that's something optional. The bare functionality to automate your home and so on, that should be really all in offline mode, working stably and reliably on the local side. And that's more or less really the infrastructure that well, openHAB has in mind, and to really make it possible for all the different devices with different protocols and so on to communicate with each other through this local home gateway. Now, Eclipse Smart Home is the framework to build such home gateways. And one of the core principles to actually achieve such an infrastructure is the Hollywood principle, right? Don't call us, we call you. So the idea here is to say, well, if a device wants to be compatible with Eclipse Smart Home, the manufacturer doesn't need to adapt the firmware to build something specific in there to make it compatible, but it's the other way around. So in Eclipse Smart Home, it's a modular software where you can simply put a piece of software on top, more or less a kind of device driver, which then speaks exactly the protocol of the device that you want to support and to bring support for this specific device. And so in practice, it's also not necessarily the manufacturers of the devices who build these software pieces, but it's really community members who say, well, okay, I have already 20 different things running which are supported, but I have this weird other device which nobody cared about yet. So they implement that, contribute it back to the project, and so there's one more support then in the end. As that, Eclipse Smart Home, it is open source, it is modular, so it's actually technically based on Java and using OSGI as a modularity framework, so that you can even, during runtime, put new drivers on top and change your setup and configuration. And well, it runs on any platform, so most users use it on Raspberry Pi or the Pine board. And I myself have it running on a Mac Mini at home, which I have in the shelf, running 24/7. And yeah, you have all these options. So to look at what Eclipse Smart Home offers as kind of services, there are more or less 4 different categories. The first is all around this device discovery, setup, configuration of them. Second part is automation aspects. Third is the data handling, be it persisting the data or exposing it to other services. And last but not least, all around user interaction, be it graphical user interfaces or also voice features. So a bit more detailed look at the architecture. So let's start with this part, the so-called bindings. These are the drivers for the devices. And Eclipse Smart Home defines an API there where you can then provide functionality to discover your devices that you find in your local network. So standard mechanisms like UPnP and MDNS, Bonjour protocol are directly supported. So it's very easy to use that. You can control your devices then, you can do remote configuration and management on them, even up to remotely doing firmware upgrades for your devices. Now, there are already, as I said, many of these bindings available. You see on the left side everything which is directly part of the Eclipse Smart Home repository. On other repositories out there on GitHub, mainly on the openHAB repository, there are many, many more. This is just a subset of what is available. So my last counting was around 70 bindings that exist so far. And there's still a long list for me to review and to merge as well. So second aspect, the rules. Actually, Eclipse Smart Home has a similar concept like if tier, just a bit more powerful. So we extended these concepts to say a rule has actually three parts. The first is the trigger on this. It's not just one trigger, but you can have a list of triggers which say, okay, under which situation do you want to start the rule? This can be events from some sensors that you get. It can be timers like run it every minute or whatever. It can be physical buttons on a device which you can use then as a trigger for some rule. Next part is the conditions. So if that. Conditions again can be the state of some of your devices. It can be the time, like saying, well, don't use this rule at night. Don't use it when I'm away, would be a state. And it can be also more complex scripting inside there. Third part, the action. What should the rule actually do in the end? It can, of course, trigger some commands for some devices, but you can also play audio files. You can do voice interaction and many other things. So this whole rule engine is built in a very modular fashion that you can also implement your own types of actions, triggers, and conditions, and they are then offered for the users in the end. So it's easily extensible. Next part is the voice enabling. That's one of the newest features. So in general, there's a kind of infrastructure to deal with audio streams. So you can define audio sources and audio sinks, or you can have some negotiation on the right audio format that both support, and have speakers like that one, or have a local sound output, microphones attached and so on, and have all these supported in there as general audio devices. Then for the voice features, there's an interface for text-to-speech stuff. So that means converting a simple string to an audio stream. There are some open source implementations, also implementations that use cloud services like the Google Translate service, where you can simply send a string, you get an MP3 file back to use that. There's also speech to text the other way around, which is a bit more complicated to implement actually. First of all, there's again the interface, which says you get an audio stream in and you please provide a string for that, what you recognized. This is a bit tricky to have good solutions that work offline stably. So most things here are rather than cloud-based, which you would access, sending your stream, getting the string back, because you usually need quite good databases of voice samples from different people to really have a reliable output here. Now, if you have such a string, it's first of all, well, the normal sentences that people say. You now need a human language interpreter, which says, well, this string is the input, and you now have to derive what are actually the actions, what should happen. This is also pluggable. You can have all kinds of implementations here. In Eclipse Smart Home, there's now a basic interpreter built in, which can control music, lights, and so the normal stuff for home automation, but you can also have very domain-specific implementations that you plug in for your own solution. Persistence, there are 3 levels of different services defined. The first is simply writing your local data away, be it in log files, be it in cloud services for further processing. Next level is also to be able to read what you wrote, and only reading for having time series to do charts and other reports from that. And the last level is then really more or less full database support, where you can also modify the history, delete data that might have been erroneous or whatever. On the graphical user interfaces, there are also some core services available that can be used for different kind of user interfaces in the end, like an icon set, or you can hook in icon sets there, which different UIs for different platforms can then simply use in the end. Same for charting engines. So if you generate images with charts, that can be then easily used in different UIs, or also HTML5 widgets for HTML-based UIs where you can integrate that. On the user interface side, well, there are quite many different choices available, starting from material design, HTML5 version, which you can use on a smartphone, tablet, or web browser, to native implementations for Android and iOS, more tablet version for hooking up a tablet or at your wall, where you have the most important information available, and so on. Then all these user interfaces use actually the REST API to communicate with the runtime stack. And the REST API more or less exposes all the functionality of Eclipse Smart Home to the outside world. So it's really very, very flexible. You get all possibilities through there. As REST API is usually not very good for providing data from the server, because you have to poll it all the time. We also have server-sent events, SSE support in there, where you can simply subscribe for events and you get them pushed to your client. And well, the REST API, you can easily plug in further functionality for yourself. If you build a custom user interface that requires some further information, something specific, you can simply extend the REST API by your own endpoints here. Now, a generic REST API might not always be the thing that you need. There's also the possibility to build more or less custom interfaces to the outside world to expose the functionality, to expose the devices in a specific way. And this is what I call here third-party emulation. And a nice example is that there's, for example, for a bundle that emulates a Philips Hue bridge, a gateway. And so you can use the Amazon Echo to actually say, well, discover new devices. It will say, oh, I found a Philips Hue bridge with 20 lights, and I can control them. And underneath, it's really just the runtime here, which emulates that and which claims to have 20 Philips devices, although you have whatever else you have attached there, and you can control that. The same trick works with HomeKit, so you can use it on iOS Siri. You can directly say, discover the stuff, and that works as well. And there are also other possibilities like 1M2M, which is a global standard for telcos for having stuff. There's also an IFT integration on the openHAB side, which works through such a way. All right. Now, as I said, Eclipse Smart Home is really a framework, first of all, to build smart home solutions, smart home gateways on top. What I showed you is really the functionality of this framework, what you can do there. openHAB is one of these solutions, which is really an open source solution, which you can download or install it on a single board computer yourself and run it. But there are also commercial solutions that are based on Eclipse SmartHome itself. Well, one that I definitely have to mention is the one where I'm working in my day job. That's actually at Deutsche Telekom. And we're selling this Magenta Smart Home solution, which is called also KiwiCon platform as a technical platform underneath, with this gateway that you're seeing on the picture. So that's really a commercial gateway that we're selling on the German market and which runs our Eclipse Smart Home there as a core as well. There are other solutions from Jung, which is also a German market company who builds more luxury homes and KNX based installations that use that. There's an Italian startup company called IOTA who is using the framework in their startup product, and probably quite some others that I actually myself don't know about, because many people are simply consuming open source, but you as a project lead never get to know who is actually that, what are the guys doing with that. Okay, enough of the slides. You want to see something working here, I guess. So I brought quite some hardware with me, as much as I can carry in my luggage from the long way from Germany to here. And am I allowed to change the resolution back? Probably not. The recording will fail then, right? Shall I have a try? Because otherwise it will be really small for you. Seems to work. Very good. So what I have here is that I'm now using simply my computer as my home gateway. So imagine this is a Raspberry Pi or something. I'm just running openHAB now right here from my IDE. Launch it here. And give it a moment to start up. Looks all good. Then we can go to the web browser, access the local host here, or server, and it comes up with the different user interfaces that are available. We see here the REST API, which is even on the runtime then used to have really the nice documentation based on Swagger, where you can directly try out the stuff. You see what is sent, what you get as a response, and that's pretty cool because you can directly interact with the system with the REST API in a very nice way here. Okay, but what I want to show you is the paper UI, which is the user interface that is used for the administration and the initial setup of the system. Now it says the inbox is empty, which is really weird. It's weird because I deactivated my Wi-Fi. Okay, so I was completely offline. My computer, it couldn't even hook up to my intranet here. So maybe first what I should mention, down here is my router. So this router has a local network here for myself. So my devices are hooked to this router. My computer is hooked up to this router, but I'm otherwise completely offline. So there's no internet connection here of my system. So now that we're online, let's see, we can go and search for devices. I should now hopefully find them. Am I? Oops. Smart Home Demo Network. Search again. It should now find my stuff, but probably, no. The problem is I started the runtime without any network interface available, so it didn't even register on the network interface. So let me restart that. That makes it better. Yeah, you have enough to eat, I know. Okay, so it's up again. We're doing a refresh here. And you see some things are automatically popping up directly. So let me start maybe with that one here. That's the Color 1000 LiveX bulb, which is hooked up through the Wi-Fi, and you can control it directly through some very proprietary weird UDP protocol. And we can now simply say, okay, this one we want to use, add as a thing. we go on our control panel, we see it here, and I should be now directly able to take control of that and make it less bright so it's easier for the eyes. Okay, so that that was easy. The other device, the other light that I have here is Philips Hue. Philips Hue is a little bit different situation. What you find here is that it has discovered a Hue bridge, which is this little round device on the floor here. It's really hooked up to the network, and it's then gateway to Zigbee. So it's speaking Zigbee light link protocol with this lamp then. And so the first thing I have to do is to say, okay, I want to use this bridge, but then Philips has implemented some authentication mechanism, so I can't actually access it. So let me go to things where this is. We see it says it's offline, and it says here not authenticated. Press pairing button on the bridge. Well, let's do that. So just pressing there should be enough, because openHAB tries every 10 seconds now to re-authenticate with that. And if we're lucky, yeah, there we go. It says now it's online. And we also see there's a new inbox entry, a Hue Bloom, which is exactly this device, because now openHAB was able to read the lights that are registered on this bridge and find that here. So we say let's add that as well. Can have a look at it, and well, it also provides color functionality, but we can also see that it has some more features like an alert. We could add that as a functionality. And so we have here, first of all, the same control. Okay, I can see the colors a bit brighter. Have that under access directly. And we also see that it now has here the alert functionality, or I can say long alert, and that's really a built-in feature in the hardware. So which says, okay, it now does some kind of alerting. So that's possible for the Bloom. The LiveX, on the other hand, has functionality like also just changing the light temperature from cold to warm. That's something that this device can't do. So for the color control, you have the same, but then you also have specific differences between the stuff. What else was there in the inbox? We have the connected Sonos speaker here, which we can add. And we have a Wemo plug, which is down there. So that's really just a smart plug, which can turn on and off and measure energy. And let's add that as well. And here's also an important feature. You as a user can decide actually what kind of functionality you want to use from a device. So I could, for example, also say I'm not interested in actually switching it. I just want to know the energy consumption. That can be very worthwhile to do if you, for example, plug in your fridge there and you don't want it to be turned off when you leave the house and you have a kind of all-off functionality, right? So we have now these things. Let's see if the speaker, I need my phone for that. It first needs some playlist. Here also deactivated the Wi-Fi. It's no good. Okay. There we go. So that should be now, if it's running, yeah, I can directly control that here, pause it, start it. Okay, so this is added there as well. Now, let me go to this little thing here, which is called the openHAB Designer, which also allows you to do some textual configuration. So more or less, you have two ways of configuring your system, through the user interface that I just showed, but also through textual way. And in many situations, I prefer the textual configuration because it's faster. You can copy paste stuff and so on. So let me pause that again. One thing I would like to do now here is to actually combine my light situation into one solution. So I'm saying I want to define a color. Item is here the vocabulary that is used. So you define items, which is really a functional view on what you want to do in your home. It's not related anymore to specific devices, but you really just define, you have some light, you have some music, you have something, and your rules in the end want to operate on that. Now, say color light, we can give it label text that should appear in UIs, and it's all light here. That's an icon to be used, and we can have a player item for music. Let's do that. And so far, this is only really the functional definition what you want to do. We can now use that for custom user interfaces as well, which are so-called sitemaps. So we create a demo sitemap here, and we say we want to have a color picker as a widget here for our light item, and we want the default widget for the music one. And based on that, we can now have a look at the other user interfaces. Let me make that a bit smaller to the side. Again, accessing the dashboard, and we can now use the basic UI here, for example, where we will simply see, why is there just one and not two? I forgot one very important thing here. For your site, you also have to put the widgets into a frame for some structuring. So that's how it has to look like. Now if we go here and wait for the reload of the file, yeah, we see now we have the two things, so we can control that here as well. No, we can't control anything. We have the widgets, but we didn't yet say what is actually the hardware that should be used on that. That's what I'm gonna add now. We can go through our things that we find here again and say, from the LiveX bulb, we want to use the color channel. And make this bigger again, that you can see it. Channel this one. And we also want to control our Philips Hue at the very same time on the very same functionality. So we're copying that ID of that channel here as well. And we can do the same for Sonos and music. This is our control channel. You can do the same as well in there, but I want to show you many more cool features that Barry won't understand, I'm afraid. Sorry for that. So now that we've connected that, we can go here and all the two very different devices from different vendors act really simultaneously. Well, that's bright. Yeah, and we can use that. No, I don't want to have it that bright anymore. Thank you. Okay, now we've gained a little bit. We can control different devices from different vendors with the same UI, but still it's nasty for yourself at home if you replace your light bulb with something like that, that you have to take out your phone every time that you want to turn it on or off, right? It's not really convenient. So It would be much nicer if you have really real hardware, real switches at your wall still, and be able to control that. The switches that you have at the moment, they turn off the power, which is not really useful if you want to turn it on again afterwards. So they should be powered on all the time, so you need something different. These things here are pretty cool. It's a radio protocol called an Ocean. It's doing energy harvesting, so there is no battery built inside. They don't need any power cables. It's really just pressing here the button, or it takes a bit energy, and this energy is enough to send the radio telegram from that thing. Now, I have in my computer an USB dongle that is the receiver for these telegrams, and we can now easily add that to our light here. So we say, besides these two channels, we want to add something else. I have that right in here so that I don't have to remember that, because I have to put the ID of this device right in here. So it's, if we look at that, it's just saying, well, a unique ID, which is printed on here, a certain profile saying this is actually a switch, a two-rocker switch, and I'm saying channel A, so it's the one that I'm now assigning to my light. That's more or less it. And with that, if I'm now pressing the right button, yeah, I can turn on and off my light with real hardware. Okay, another nice integration which can be useful is, okay, although the smartphone is not always appropriate, there's a nice use case where you can use it. I have an RFID tag stick on here on the speaker, and here you see more or less the same user interface. So I have the light and the music. I can now, simply by pressing long on this light widget, I can say I would like to program this NFC tag to toggle the light. So now I'm just programming it, holding it here. It says, okay, successful. And now I can simply, by touching with my phone the RFID tag, I can switch the light here. Well, that's already much more convenient than running an app. And actually what is a nice use case for that is something outside of your house. Think of a garage door or something, where you can simply stick that somewhere in your garden, wherever, and you can very easily trigger some action through that. And on the tag itself, that's only stored, please toggle item light. There's nothing else on there, so all security comes by the fact that your mobile is hooked up to your Wi-Fi, that you have the fingerprint sensor here first to unlock your phone, and that you have credentials to access your openHAB instance. So really 3 levels of security, and only you are the one who can then use these RFID tags. Okay, another feature that comes then with the mobile phone is as well that in the Android application there's directly hooked up the text-to-speech functionality. In the demo now, that will probably take a moment, because when Android is completely offline, then it waits until a timeout before it starts processing it offline. But there is offline voice recognition features, which is quite nice. So we can have a try now. Turn the light on. Maybe it's more than 5 seconds. Come on. Okay, it took a while until the timeout. When you are online, this is instantaneous. So that's really fast and quick then, and also the online voice recognition through the app is then even more reliable. But it even worked in the offline mode with my German accent, so that's quite good. You can do more or less, it doesn't matter for openHAB where this string comes from. So we can also check here on the command line. We can say here SmartHome as a command line feature, voice feature, interpret now some information like set the light to green, and it works. So we can just type normal text here, it's interpreted, and the action is executed. You can also think like, well, you're having a Twitter feed and you're using a remote control through Twitter that way, or having XMPP integration for chat mechanisms and so on. Okay, one very special device that I always like in the demos is that little guy here. Who knows that? It's a Leap Motion gesture controller. Actually, Leap Motion is sitting very close to here, just a few blocks away, I guess. And to show you what this thing does, I can start its visualizer here. So I look over here, you see that's a camera built inside there, a stereo camera. And if I'm holding there my hand, it recognizes my hand, my finger position, and so it's really used for gestures here. Even up to 10 fingers, la 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 la, works quite nicely. Now we go back to the designer, and all we have to do is to say, well, we again want to control our light item. We're still on this line, and let's add another device, which is the Leap Motion controller, and simply say true here. So Leap Motion you can only attach to one device. And now that this is registered here, let's go back here to the control to see if that is doing something. Let's give it a moment to register. Okay, refreshing, key tab. Okay, now I think it got it. It usually works better, believe me. It's only because Barry is looking at the back. Okay, now it gets better. So I can simply tap now here to turn it on and off. I can rotate my finger to choose the color, to change it. Why is it going white and green? This looks better. And I can hold my 5 fingers to dim it, lower, higher. Can do a lot of nice stuff with that. Yeah, I like that. It's nice for demos. I could imagine that one day that is also built directly in really wall switches, which would enable you to do actually more kind of interaction, like especially color control, other things that you might want to do in the homes. But that might still take a while until there are gesture controllers that are not as CPU intensive as this one, because you couldn't operate that on a Raspberry Pi. You really need some more decent hardware to run that on. Okay, but so far I've only showed you, well, not really fancy stuff. It's only controlling your devices, and you are more or less the actor. Let's look into automating a little bit here. And for this, let's go back here, and let me maybe start with that little thing. It's another piece of hardware that I bought. It's a Flick push button. It's a Bluetooth low energy device with a coin cell built inside. And if I'm pressing here, it sends really just a small signal. At the moment, it's not directly hooked up to openHAB, but it's sending the signal to the smartphone. The smartphone then is programmed to do a REST call to the REST API of openHAB to say an item called doorbell should be sent on. So what we need to do is to add a new item here, saying it's a switch called doorbell. We only need to define that here because it will be operated through the REST API. If I'm pressing here, not much will happen because there is nothing special given yet, so we can define a rule for our doorbell. Let's say we want to create a new rule here, call it doorbell. We define a trigger, which is now an item state update on some item where we now need to check for our doorbell item. Okay. And as an action, we can now specify here that we would like to play a sound and use a doorbell sound for that. We save that, and now one thing I need to further configure is that on our Sonos speaker, which I would like to use as my speaker for that, there are not only these functionalities available, but if we click on show more, there's a lot more stuff, and I want to enable now notification sound volume, which means that this speaker is able to play notifications now. It's actually all through software. By the hardware itself, it can't really do that, and it wasn't easy to build all that. But we can now define, okay, notifications should be please very loud, the music not so loud. Okay, so we hear the music playing. You see also if I'm adjusting the volume here, it's directly changing on the UI as well. And now we can have a try with our doorbell. Just missed to switch back to the music play. That's not fair. Okay, let me give it another try. Okay, it resumes the music afterwards. So technically it really replaces the playlist in between, brings it back on, changes the volume and so on. Okay, so that's a normal doorbell. Not too fancy yet, but we can enhance our rule and say, well, actually, a doorbell I only need while I'm at home, right? So let's make something different while I'm not at home. So first of all, we need to now define a new information like, well, we are at home or not. For this, we again add a new item, a simple switch that we call presence. And to make it easy to switch it, I'll just use again an ocean button, and this time the channel B, so it's easy that I can change that. And if somebody now asks me what is the safest way to detect whether somebody's at home or not, it's definitely having a real button at the door that you're pressing and you're saying you're now leaving the house as the last person. Everything else simply it doesn't work reliably, especially not if you have kids and pets and whatever. That's the best way to do it. Okay, so we now have this presence. We can add that to our demo sitemap here as well as a switch item presence, so that we can see that the switch is working and what's our current state. Reload, there we go. Okay, go in there. Okay, back to our rules. We wanted to say that this rule should now actually only run under the condition that we are at home. So an item state condition we choose. And we say that our presence should be equal to on. Okay. Oh, and actually another nice feature that we can add here is we add another action, sending a command, because I showed you the nice alerting functionality. In case you're not hearing that well, you can use that as well. So we can say alert, and that was a command L select, which this supports to blink long. Okay. Also change the order here, save that. And now, well, this is the rule for we are at home. Let's create a second one to say scare people away when we're not at home. So again, we're using the item update of our doorbell. We're saying as an action, we want to again play some sound, but please this time let the dog bark. And only under the condition that our presence is off this time. Okay, we save this rule. Now we are at home. So we see the Philips Hue is also giving us a signal that there is a doorbell. We are not at home anymore. Ah. That's my. Okay, you see which one is running. Good. Now you might say, well, that's actually again a special situation for Barry. It's user friendly. You have the UI to define a rule, but as a programmer, you say, that's nasty. You actually did an if then else right now, but you had to create two different rules. You had to click 20 million times around. So actually doing that as a small script is much easier and straightforward for any tech-savvy guy. So we can also now have a look at here the textual designer again and create some rule on a textual way. For this, we have also some IDE support like completion templates available here. So as an example, let's say we're defining a rule, we're leaving the house. Let's call that simply leaving. When the state changes, the state of the presence item changed to off. Then we can do some more specific things, like we say, well, if we left the light on, now normally the state of the light is some color value, so we can say get state as on off type. And if this is on, which means we left the light on, then, well, tell us please. You have left the light on. And it would be, of course, also nice if it would directly command turn it off for us. And otherwise, it could say goodbye. So that's a textual rule now, and let's have a try if that works. Let's turn on the light. That still works. Presence. Tuck, 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 tuck. The presence one doesn't want. I do it that way. So we're leaving the house.
You have left the light on.
Yeah, so it reminded me. For lights, you might say, well, turning it off is good enough. I don't want to be reminded. But for Windows, that's very convenient because they usually can't be automatically closed. And that's also a use case that I have at home, that if you're leaving, you're really reminded if some window is left open. And so you know that you still have to do something. Quite useful.
Goodbye.
And now, if we're leaving and everything is fine, goodbye. Good. So these are these rules. Now one thing which is a good example also how not to build firmwares in devices. The Wemo plug is supposed to be my hardware device now to measure energy and to have an energy consumption available here. Unfortunately, this thing has a firmware bug that if it's offline, it actually doesn't ever report the energy consumption. If it's a single second online on the internet, it seems to send some secret stuff to Belkin, to the servers. Once it did that, then it will report offline all the energy consumption all the time. Now that I plugged it in here and I'm offline, it simply will report 0 watts all the time, nothing else. But that's a good opportunity to show another feature. We can simply simulate now this value. So on the control panel, you have seen right here, we have this power information, which is 0. Let's simply create a simple rule that creates us some fake values. Fake consumption. And as a trigger, we can now say, well, let's use a timer trigger. And this is a very generic one, which takes a cron expression, where it can very detailed specify on how often that should be executed. I have that here in my snippets. So this cron expression simply says trigger this rule every 3 seconds, very easily. And as an action, that's now a bit more complicated. So we're using a script action, and this actually allows now to provide some JavaScript right in here, which is then executed on the runtime dynamically through the Java built-in JavaScript interpreter, the Nashorn engine on Java 8. So we can define variable power, can access directly Java lang math here as well. Oops. Random, and say, let's do 2000 watts here, a value between 0 and 2000. And now we can use the events to post a state update event with the value of our power. And right in here, we now have to specify where this should be sent. For this, we can quickly go on our command line, say SmartHome items to list them. And there's the Wemo inside entry current power. So we're copying that line and saying, this is where we're sending that. Okay, save. And we're now going back here. We should have power values updated every 3 seconds. It's that easy. Okay, with that information at hand now, I want to show you another cool feature, which is meant for guys like Barry, sorry, because it is a complex rule, but it can be prepared by some developer and can be then easily instantiated by regular users in the end. We call that rule template simply, that can be registered in here. It's a bit similar to if recipes, where you also say, well, okay, somebody has put together a recipe, what is a nice use case, and you just say, well, you want to use that and configure that. So for this here, you can say rule from template. I have prepared one of these recipes templates, an energy meter, which, as a description says, well, it visualizes the current energy consumption on the light. So green means low energy, red means a lot of energy. And all we need to do with this is now to configure it, to say our consumption item, the input is right this one here. Our color item, what we want to switch, is our, not just the live X bulb, but we have our light, right? Light item that we defined. And then here we have to provide what is the maximum value of watts, so where we want the light to be red. We've now did 2000, so we fill that in here. We save that rule, and immediately it starts working. And if we look here at the values, we should see that was almost 2000 before, it was red, now low value, more yellowish tone. So it's immediately working as a use case. And we can have a quick look at what this rule template actually did. And this, again, a trigger which is only reacting on changes of the current power value. And as an action, it's also having a JavaScript inside, which calculates from the power value now a U value, which is then sent to the device. And you see that the things that we selected as the 2000 watts and so on, that had been filled in here into the placeholders that were prepared. So it's very easy really to create now more complex use cases and have them shared in the community and find something for your own. Okay, let's disable this rule again and return to our slides, because that was the live demo. Just a few words now about openHAB and its community, what's happening there. So openHAB itself now, the distribution that you can download as a zip file or also as a Debian package or whatever, it's more or less a packaging of different kind of projects. So we're using Apache Giraffe as a more or less framework to provide start scripts and so on, and some management. Eclipse Equinox as an OSGI container. We have Jetty as an HTTP server bundled on that. We have the Eclipse SmartHome libraries that really run the core parts. And we have then all kinds of extensions like the user interfaces, like the bindings, like text-to-speech engines and so on, which come from different repositories, be it from Eclipse SmartHome, be it from openHAB. All of that is assembled in really one big package in the end. On Eclipse SmartHome, just here some statistics. So there's a reporting that runs automatically at Black Duck, which says here, well, there are 78 developers who contribute to code already, so that's quite many. It's one of the largest open source teams in the world. I don't know, that's what they claim. Top 2% of all the projects that they analyze there. And yeah, it's very high activity, and you see at the charts, especially since around early this year, there's even much more activity than before, and that's mainly because I asked all openHAB developers to join on Eclipse SmartHome development at that time. So since then, there's really a lot of contributions coming in and a lot of activity around that project. Over the history, the number of bindings and add-ons on openHAB has grown quite rapidly, and the only limiting factor there is more or less that I insist on code reviews on the stuff and having really a good and clean code base altogether. So I'm a complete bottleneck on the thing because I'm mainly the one who does the code reviews and merge it finally. So there's a long pipeline of further contributions and further bindings, and it could be even much more if there would be some more help on that part. Now, to organize the whole project, we've recently created a non-profit organization that should try to help with the whole maintenance of this project. Because we not only have this distribution which is packaged, we have a sub-project that deals with the Debian packages, we have a sub-project for Docker containers, we have a sub-project for the whole documentation and tutorials for people to get started. And yeah, many different people are helping there, working there. And we really want to have a kind of legal entity now to maintain this whole project and to hold it together. And also to have companies helping there by donating our money so that we can have more things organized altogether. Because so far it's really the whole community doing it completely in their spare time, and it's a lot of activity that goes into that project. And we even have an office, which is this little telephone booth in my garden. It's exactly 1 square meter. So not all members, these are the founding members, we don't fit in there, unfortunately. But yeah, it's a starting point as an office. And with that, well, I would like to thank you very much for your attention, and would be there for Q&A.
Testing.
Hi, thank you for the presentation. I was wondering, what advice would you have for somebody who has close to zero knowledge on like smart home or IoT to get started and use your framework?
I think there's no general answer. It really depends on what's your interest. So you can have more or less 3 kind of categories of use cases where you can get started. The one is more, well, the comfort stuff where you say, well, okay, you want to have stuff like, well, turning off the lights when you're leaving the house, which is already a bit more complicated because you have to replace quite a lot of hardware. Besides comfort, the second part is more energy related. You want to maybe more efficiently heat your house or cool it and have HVAC working there. So that's something. And the third part is more security related. You want to be notified if there's a window being opened while you're away and stuff like that. So these are more or less the three different kinds of use cases, areas where you could explore. And so it depends on really where you want to go after and maybe what kind of hardware you might already have at home that is suitable to be connected to other stuff. Like many people have something like a Sonos speaker already at home, so you could start using that just as a notification device that I've showed here. So yeah, I think there are many, many different options, and it's really, yeah, you need to know what yourself are most interested in.
Thank you. Any other questions?
So if someone contributes to your foundation here in the U.S., is it tax deductible?
We need a good lawyer to get that tax right here. In Germany, if you have a German or even, I think from Germany, it is tax deductible. So that's also why we set that up, because it's easier to get donations then. For the US, I know that there are organizations that help German nonprofit organizations to also be tax deductible in the US and to have that forwarded. But yeah, it needs really some work and stuff. So once there are many people from the US who say, well, okay, we want to donate, but only under this condition that it's tax deductible, then we will look into that.
We'll be waiting for the openHAB political action.
Anyone else?
So who are the primary users of openHAB? Is it usually people like, well, I'm assuming like us who would be tinkering with it in our own homes, or are people using it for commercial products?
It's mainly people who are doing it for their own homes, or usually tech-savvy people, because what you have to do is to somehow do an SD card image or install it yourself on some hardware and figure that out. But yeah, as numbers, I can say that there are definitely more than 10,000 installations are out there of people who are using it. It's really very international, so most users are between Europe and the US. It's about 50-50, so not that much in Asia or Africa or anywhere else, but Europe and US really the biggest blocks. And I've also learned from many users that they not only run their own installation at home, but also for some of their friends or neighbors, because they came and said, oh, that's cool, I need that as well, but I can't do it. So they set that up for a couple of other people as well. And there are also now a couple of users who say, well, they actually want to do that for a living, to actually offer installation services and consulting around that, to do that for other people in their region and so on. And besides the openHAB project, as I said, the commercial solutions, this is then a different topic. This is really targeted at the mass market for the average user. But there you definitely wouldn't have to do any textual configuration and so on. So that's why also all these contributions about user interfaces, having nice ways to interact with the system and make that much easier from entry level, that has been contributed by such companies.
Very interesting. Any other questions?
I had two questions, actually. One is, does this work with specifically open hardware, or is it interact with all kinds of devices if the spec is not?
Well, I think hardly anything that I brought here is an open device, right? Open hardware. So these are really all products off the shelf from manufacturers that don't necessarily had in mind that these devices are connected. So, okay, the lights, they definitely targeted developers to open that up. The Sonos speaker, that's rather reverse engineered the UPnP communication that it does. So Sonos didn't have a developer API available here at all, so that's reverse engineering on that, also on many of the other devices. So more or less everything that you can technically connect to in some way or through some weird protocol which might not be documented or might be documented is connectable there.
Okay. And the second question is, just reading on your website, you are primarily targeting micro, tiny, like Raspberry Pis and low-end hardware. Why did you choose Java? It has a reputation to be fairly fat.
Well, I not only chose Java, but also OSGI. And if you know what OSGI standard for in the past, is Open Services Gateway Initiative. So the original idea of OSGI was exactly that kind of device, to target home gateways where you can dynamically add services or remove them and so on. Well, that's only part of the answer. I agree that having the JVM and all the stack is usually heavier than choosing some other languages that you might normally use. For me, the main reason was that at the time that I started the project, I was working as a professional Java developer on Eclipse RCP applications, actually in the banking industry at that time. Very boring stuff. But Java and all the tooling, that's what I knew from my day job. And the open source projects that I looked at, so that was, for example, one called Mr. House, written in Perl. So Perl might be decent on that, but Perl as a language, as you know, might know, it's a write-only language. Yeah. So just writing the code, but nobody is ever able to read that again. And this project looked like that as well. It was already 10 years old at the time that I looked at it. It started in the end of the 90s, and many people somehow did something on that, and it was simply a nightmare. And I looked at that and said, well, I don't want to run my house for the next decades on such a code base. And that's why I really said, well, okay, Java with all the tooling, IDEs and so on is really a language which is there, which is supposed, hopefully, there for a longer time, and really something decent. And yeah.
So what's the status of OpenJVM versus Oracle?
OpenJDK, you mean? Well, the status is that there's now a company called Azul Systems who's specialized on building OpenJDK versions for ARM as well. And they just about a month ago launched that on their website to have really ARM builds of OpenJDK, which run in my early tests as good as the Oracle JDK. So for the ones who are not too familiar with all the licensing and so on, the Oracle JDK is offered for free for developers, but as soon as you want to package that in a commercial product that you want to ship, you have to pay licenses for that per CPU core and so on. So it's not necessarily a nice option to have directly to pay license fees to somebody if you're packaging a product. So the OpenJDK version is really the pure open sourced one. And these Azul JVM is then a good alternative to that. I think so.
We have time for one or two more questions if anyone has any final remarks. If not, thank you again to Kai for joining us this evening. It was a wonderful talk. This has been a Women in IoT meetup. We are having Benjamin Cabet give a workshop sometime later this month or early next month, in the next couple weeks. Like us on Facebook, join our meetup group, and you will find details about that next event. Thank you again, and thank you all for coming. Have a good night.
Thank you.